Okay, we've got parametric differentiation again. So we're going to do the same as last time. We've got x in terms of t, y in terms of t, so we're going to get dx by dt, and we're going to get dy by dt, and then we're going to combine them to get dy by dx. So differentiate 3t, we get 3. Differentiate t squared, we get 2t. Formula for dy by dx, we're now going to rely on knowing that it's dy by dt divided by dx by dt. Get it the right way up. You'll always do dx by dt first, but that will always go on the bottom of this fraction. So dy by dt is 2t on the top, dx by dt is 3 on the bottom. Okay. Alright, now in part 1, we've got to find the equation of the normal at the point where the x-coordinate is -9. Okay, so I've got dy by dx, and the normal is a straight line, so I need a point and a gradient. Okay, so I need a point, I need a gradient. Well, my point is going to be -9 for x, but I need to know what y is. So here's my equation of the curve, but it comes in these two things. But knowing that x is -3t, if -9 is 3t, that means that t must equal -3. So knowing that t is -3 is enough to work out y. Y is t squared, -3 squared is 9. So the point is -9, 9. Now the gradient, well, the tangent gradient is dy by dx. So the tangent gradient is 2 times -3 over 3, which is -2. But I'm working out the gradient of the normal, because I want the equation of the normal. So therefore the perpendicular gradient, which is the one I want, is the negative reciprocal of -2, so it's a half. So my equation of my normal, so this is the normal, working out here. Okay, so my normal has equation y minus y1, so that's y minus 9 equals m, which is a half for the normal, minus 9, sorry, x minus x1, which is x plus 9. Okay, get it the right way around. So that's my normal equation. That's fine. I could simplify this if I wanted to, but I'm going to plow on and do part 2, which is to find where does the normal meet the curve again. So now I've got to solve the equation. Here's the equation of a line. Here's the equation or equations of the curve. It's effectively simultaneous equations. But in fact, when this is parametric, solving the simultaneous equations is always really, well, quite easy to get started anyway, because I've got an x and a y in terms of t that I can just plug in. So this equation here, I'm going to be saying that y minus 9 equals a half of x plus 9, okay, where y and x are their formulas in terms of t. So y is t squared and x is 3t. Y is t squared and x is 3t. So we can see this is going to be a fairly friendly quadratic equation in t. So t squared minus 9 equals, shall we multiply by the 2? So 2 is t squared minus 9 equals, I've got 3t plus 9. Now I've multiplied by 2. So I've got 2t squared. I'm going to have minus 3t. I'm going to have 2 times minus 9 is minus 18, but I'm taking away another 9. So that's minus 27 has to equal 0. So I solve this quadratic equation. Oops. This is a quadratic equation. I've just written down 2t squared from here, minus 18 from there, minus this 9 that I'm taking away, minus the 3t. So that's a quadratic equation. Now, I could reach my calculator, but I know one of the solutions. I know that there's some kind of curve going on. I've got a normal to that curve at right angles to it, which is meeting the curve again. But one of the intersections is the point I started from, which was when t equals minus 3. So because I know one solution for t, I know one of the factors is going to be t plus 3. So it's very easy to get the other factor, which has got to be 2t, and it's got to be minus 9. And I can check that works out. 3 times 2t minus 9 times t does equal minus 3t. So I've solved my quadratic equation. I'm going to get t equals minus 3, or t equals, from this one, 2t would be 9, so t equals 9 over 2. And t equals minus 3 is the solution I already knew. That's the point where I drew my normal. It's the other point where the curve, the normal, it says meets the curve again. So that means I want the other solution. So that's when t is minus 9, equals plus 9 over 2. Now that's not the point, that's just the t value that generates the point. So I can go all the way back to my x and y recipes. X is 3t, y is t squared. So x equals 3 times t, y equals t squared. T is 9 over 2, I now know. 9 over 2. So x, 3 times 9 over 2 is 27 over 2, and 9 over 2 squared is 81 over 4. Okay, is my point, so I underline that, that's my answer. Okay, now the third part asks me to do something, okay, more general. It asks me to say, well, we're not telling you what t is this time. In fact, let's just say you've got the point 3t squared. That's not just made up, that's just using the x and y things in terms of t. So without knowing what t is, we can still go through the same procedure for finding the normal. I still need a point and a gradient, okay? So this time they tell me to use that general point. So the point, no work to do, it's just 3t, t squared. And the gradient, well, the tangent gradient, I've already worked this out in terms of t. So I've worked out dy by dx was 2t over 3. Now for the previous normal, I actually substituted a t value in and I took that numerical value forward. What I've got to do is go back to the original gradient of the tangent in terms of t. So the tangent gradient was 2t over 3, 2t over 3. Not cubed. So therefore my normal gradient is just going to be the negative reciprocal of that, which is minus 3 over 2t. So I've got to do the normal thing, the y minus y1 recipe. So y minus, my y1 is now t squared. So although we don't know what t is, we're thinking of t as being a constant. There is some number, that's the y coordinate, which is t squared. I just don't happen to know what that number is. And then on the other side, I need my m, which is minus 3 over 2t. Okay, and then I need x minus x1, which is 3t. All right, and I can multiply this by 2t, I suppose. It's marginal about whether we'd need to do that, but let's do it. So 2ty equals, minus 2t cubed equals, multiply out the brackets, minus 3x plus 9t. I'm going to leave it there. Oops. So I've multiplied this by 2t. I've multiplied that through by the minus 3. And that's my equation of my normal. Now that, believe it or not, is a straight line. Okay? It's a straight line because 2t and t cubed and 9t are all fixed numbers in terms of t. I just don't happen to know what t is. So we've got a constant times y minus another constant equals a constant times x plus another constant. Because we're imagining we've fixed one point, we've got a particular value of t in mind, we just haven't been told what that value is. So this, although it looks more complicated than a line, really is just the equation of a straight line.